Welcome to qnawire.
For this problem on the topic of sources of magnetic fields, we are told that a pair of point charges each have a charge as given, and they are moving with speeds which are also given. Now, when the charges are at a point as shown in the figure, we want to calculate the magnitude and direction of the magnetic field produced at origin, as well as the magnetic force that charge q prime exerts on q. Now we know that a magnetic field due to a moving charge, B, is equal to mu naught over 4 pi times qv sine phi over r squared, where q is the magnitude of the charge and v is the speed. So for the two moving charges, their magnitudes add, producing a net field B net, which is simply the sum of the two fields B plus B prime, which is mu naught over 4 pi into qv sine phi over r squared plus the field due to charge q prime, which is q prime v prime sine of phi prime over r prime squared. Now, if we substitute numbers into this expression, we can find this magnitude of the net magnetic field. So this magnetic field magnitude is mu naught over 4 pi. We know mu naught is a constant. 4 pi times 10 to the minus 7 in SI units into 8 microcoulombs times the speed, which is given as 9 times 10 to the 4 meters per second times sine of the angle 90 degrees divided by r squared, which is 0.3 meters squared. This is plus the values for the q prime charge, which is 5 microcoulombs times its speed of 6.5 times 10 to the 4 meters per second times sine of 90 degrees divided by 0.4 meters squared. And so calculating, we get the net magnetic field of the two moving charges to be 1 times 10 to the minus 6 teslas, which we know is simply 1 microtesla, and both these fields are into the page, so the resultant field is also into the page. So we have the magnitude and direction of the resultant magnetic field. Now, for the second part, we want to calculate the charge that q prime exerts on q, or the force rather, the magnetic force that q prime exerts on q. Now we know the magnetic force F is equal to qv cross b, where b is the magnetic field and v is the velocity vector. Now, the magnetic field of charge q prime at the point at which charge q is, we know is into the page. And so the force qv cross b is equal to qv in the I direction, and this is crossed with mu naught over 4 pi, which is a constant, q v prime crossed with r hat. And this is divided by the magnitude r squared. So we can write this as qv I hat cross, so that's I hat, the I unit vector, crossed with mu naught over 4 pi times q v prime sine phi over r squared, and this is, so v cross r hat gives us the unit vector minus k hat. And so if we perform this cross product, we get the force acting by q prime on charge q to be mu naught over 4 pi times q prime v prime sine phi divided by r squared, and all of this times the unit vector j hat. So the force due to q prime acting on q acts along the j direction.